just as a review of last time, right? We saw some questions that said, if the absolute value of x is equal to, let's say, 5. Okay. And then the question might ask you, what are the possible values? What are the values of x, right? And in that scenario, you have to be very clear on what they are asking you. They are saying x is a number that has a distance of 5 units from 0, right? That is our definition of absolute value. So if we think about starting on the number line at 0, and if we walked 5 units in one direction, we could get to the number 5, positive 5, right? And that's 5 units away from 0. It's sort of what gives that number, positive 5, its size. Okay, but we could also start at 0 and walk 5 units in the opposite direction and be located now at the location of negative 5. So there are two values that could be, that have a distance of 5 units from 0, right? And that's what absolute value is. But if you have a question that says something like this, if the absolute value of x is equal to, let's say, negative 10, what are the values of x? Okay, this is a slightly different question, and we have to remember what the definition of absolute value is. Okay, so this is saying we need some number that is a distance of negative 10 from 0. So last time I made a note that distances are always measured in positive values.
And I remembered that, and I thought that that meant that then it would just be positive 10.
No. So if this question is asking you the absolute value of this number is negative 10, there is no number that you can throw into the absolute value operation that gives you a negative value in the end.
Okay. So whenever it's a negative, the answer is just going to be no solution.
Yeah, there's no solution because there are no positive, I'm sorry, there's no negative distances.
Oh, okay.
That is different from saying something like this. This is a different question, right? The different question would be like, okay, what is the absolute value of 10? That is just 10, right? That is the distance that 10 lies from 0. Ooh, there we go. And then if I ask you what is the absolute value of negative 10, again, that's asking you, okay, we're at the number line at negative 10. How many units away from 0 am I?
10.
10, right? But that's different than saying that this number, whatever it is, has a distance that's negative. So you just have to be very careful with that.
I see the difference now.
Yeah.
Yep, that one got me a couple times last night.
Yeah.
I was like, I don't know why. And then I was like, okay, it's no solution, but I don't get it, but okay.
Yeah, so just remember that if you are ever stuck on something like that, there's two options for you if you can't get access to me, or I'm not able to respond to your email or message. That is, you can go into the Learn section and look for that material in Hawks, right? Because that should supplement what we're learning in class. Or if there's still time, right? If you're still within Math World's hours, I suggest that you pop in with Math World tutors and just have them explain it to you, right? They're sort of like the instructors outside of our class time.
Okay.
Right, so if you're not able to access me, you have these other support materials or support services that you can access, so that you don't have to be like racking your brain trying to figure out like, why does this keep telling me that I'm wrong?
Maybe you explained this before, but is it that Math World is virtual right now?
Right now, for the first 2 weeks, we are virtual. So it's all through Zoom, and it's an on-demand service, right? So you can click on that link that I provided in Canvas, go to the Math World Canvas page, and then find the tutor that is available at the time that you need them.
Okay, good.
Yeah, and then you just drop into their Zoom session, and then they'll let you in, and they can help you out. You can screen share with them if you're on a laptop or a MacBook.
Cool.
And then they can see what you're working on. They can help you through it, explain it to you in a little bit more depth than we have, in lecture, because I sort of have a flow that I have to get through, some material to cover.
Yeah.
So outside of class, there's more room to sort of breathe, and actually, if you have those confusions or questions, you can clarify them there.
Okay. I think I came in on one day on the tail end of you explaining how Math World is now, and that's why I was asking, because
Yeah, no, and when we go back face to face, they should resume remember, they have limited face-to-face hours. So you'll just have to check to make sure. I think it's like Mondays, Wednesdays, and Thursdays or something like that. But just check the page.
Will do. Thank you.
You got it.
There's a lot of lag on today's Zoom call.
It is.
I
thought I was the only one. But
definitely, there is a lot of lag. Like, you're way behind. Like, I see you coming and going.
Let's see. Okay. Am I lagging right now?
No, you're good.
Fine now.
yeah.
Okay. If at any point I'm lagging, just go ahead and let me know by putting in the chat. And I'll try to be mindful to check that so I can slow down, let it catch up. I mean, this is just something that we're going to have to deal with as we are remote, right?
Yeah. Yeah.
Okay. Let me go ahead and switch back to my document camera. Okay. Today we're going to be starting section 8.2, and we're going to be doing addition with real numbers. This might seem very simple, so if it is, just bear with me. But what I hope to do is clarify the rules of addition so that we don't make what will later be minor arithmetic errors as we get into more complicated problems. Okay. So when we're adding, we sort of want to think about addition as a process that performs an operation on numbers, that it actually performs an action. Okay. So addition, and you want to sort of visualize yourself as standing on the number line. And when we add two numbers together, it performs the action of sliding our position or our location either to the left or to the right, depending on what number we start with and what number we are adding. Okay, so addition performs the action of sliding either left or right from some original location on the number line. Okay. When we add integers, that's probably the easiest way that we think about addition, because we can visualize, the tick marks or those little dash marks on a number line. And so if we needed to draw a picture of an addition problem, let's say that we had 5 plus 3, and we want to visualize this. Well, we probably already intuitively understand that 5 plus 3 should be 8. Okay, that makes sense. You know, in grade school, you probably learned to count with your fingers, and if you had, you know, manageably small numbers, then you could just use your fingers to count 5 plus 3 more, and then you just count them to get to 8, right? But we want to use this intuition of sliding on the number line where we start at 5, and we want to move 1, 2, 3 tick marks over. So we're literally moving 3 units, and that's what it means to add 3. And so that's how we get to the location 8. That makes sense? But I want to clarify that we started with a positive number. And we added a positive number here. Okay. And then we ended with a positive number. The result was positive. Okay, so if we add 2 positive numbers together, it seems like we should get a positive result, right?
Correct.
And I want to understand why that is. Okay, well, it's because when you add a positive number, you're moving to the right. And remember that all of the negative numbers live on the left side of 0. So if we're still moving to the right and we started on a positive number, then we're going to still end up on a positive number. So adding a positive number moves us to the right. Or you might say in the positive direction. Okay. So that's adding 2 positives. But now, let's add 2 negative numbers together. So let's say that, and usually, and you don't want to sort of get confused by this, a lot of times you will see in parentheses, we'll put -5 plus -3 like this. Okay, and I want to make a note here that the parentheses are just trying to clarify for you that we're dealing with negative numbers, right? Because if we had a bunch of like addition signs and minus signs next to each other, it gets really confusing. So the parentheses are only here to clarify that the numbers are negative. Does anybody happen to know what you get when you add -5 and -3?
-8.
Yeah. Does this make sense to you guys, or does anybody, does anybody have some confusion or maybe some dissonance here? Right, because we have a -5 and we're adding a -3 and we get a -8. Now I assure you that that is correct, but I want to be very clear, we're adding a negative plus another negative, and the result is negative.
Mm-hmm.
Does that make sense to everybody?
Yes.
Okay. Now the reason why that is because we're on the number line. And if we start at -5, let's say -5 is right here, and we add -3 to it, we should end up at -8. So what we're doing is starting at our first location, moving over 1, 2, 3, but we went 3 units to the left. Okay, so when you add a negative number, that's going to move you to the left or the negative direction. Does anybody have any questions about that?
Mr. Aguilar, my thing is a little behind. I don't know what's going on with my laptop. So I'm having to do my Zoom on my phone today.
Okay,
Because it's not letting me log into any of my ACES, any of the web browsers. So
Okay.
it's just a small delay in between what you're saying. So if I ask the question, it's only because it blanked out.
okay, no, that's fine. Some of the other students also mentioned that there's a
It's,
lag.
It's lagging again.
Okay. So if I could ask, whenever you unmute yourself to speak, remember to mute yourself again in case you have a noisy background.
Oh,
Okay. Am I still lagging?
no, you're
Okay.
not.
Okay. So that might seem like a really silly set of examples, right? Especially if you're already pretty clear with the rules of addition. But I think that the issues that students will run into is whenever you're adding and subtracting, or rather adding numbers that have different signs, right? So in those other examples, they had the same sign. We had +5 plus +3, and we ended up with a positive result. We have -5 and -3, and we added those together and we got a negative result. That should make sense. But when we add numbers with different signs, that's where things can get a little bit trickier. So with different signs. Okay, so let's look at some examples. If I had the number, let's say 10 plus -7, does anybody know what the result should be?
-3.
No, +3. Yeah,
See, and
+3.
Yeah,
See, this-
+3. I'm sorry.
Yeah. So, but it's easy to make those mistakes if we're going quickly. Whenever we start switching up the signs, you're right. It should be +3. I'm going to put a +3. We don't have to put the plus sign in front of positive numbers because it's sort of automatically understood that if you don't put a sign, it's positive. But does this confuse anybody? And this is the place to clarify that confusion. I want to make sure that nobody's suffering in silence here.
No.
What is it? It sort of looks like we're just subtracting though, right? It's like we ignored this sign and just did 10 minus 7, and that's equal to 3, right? Well, the intuition that I want you guys to have in your head always is that we're adding a negative number here. So let me go ahead and saying, okay, this is our start location, our starting number, and this is what we're adding. Adding a negative, and that should move us to the left on the number line, right? So if you think about the number line here, and we start at 10, and we want to take 10 plus our -7, that means that we should be moving from our starting location in the left direction, 7 units to the left. Sorry for squeezing that in. And then this should be a smaller number because we moved to the left. So it should be 3. Okay, let's try something different. Let's try another example. -8 plus 14. Does anybody know what this should be?
Six.
Yeah. +6. Is anybody confused as to why this should be +6?
So basically you're saying anything that, you know, even if like a positive adding with the negative number is always going to be a positive.
No, that's absolutely not what I'm saying. In these two examples, that's sort of what it looks like, right? But maybe in another example, it'll be a little bit clearer. Let's go ahead and visualize this on the number line though, right? Let's say that we started at -8 and we needed to move 14 units, and I wish I hadn't used such big numbers now, but we need to move 14 units to the right because this is positive, right? So we're going to move 14 units, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then we end up right here on the number line. And we wouldn't want to do this in practice, but you know, we could say that this is -7, this should be -6, -5, 4, 3, 2, 1, 0, that should be 0. And then we get to the positive numbers, so that should be 1, 2, 3, 4, 5, and then finally 6. Right, and that is by adding or moving 14 units to the right. So it really depends on the location that you start at. Because if I gave you another example, let's say we'll start at -8 as well, but I'm going to add 5 instead. Okay, what should the result here be?
+3.
It'd be -3.
-3.
So it
Yeah,
can't be,
-3,
it
I'm
can't be
sorry.
positive or -3. It has to be 1, right?
No, it's -3.
It's -3. But what
It's
was the
-3.
what was the mistake that you were making in your head initially?
It was just I was moving the wrong. I wasn't thinking about using it like how you've been doing on the number line, moving left
Right.
to right. I
You
was
sort of-
thinking about the function, like, and I messed that up. So
Yeah, I think like in your head you were doing a subtraction and you were like, okay, it has to be 3.
yeah, exactly. That's
And then you
exactly what I was doing.
And then you were just making it positive. You were just like keeping it positive and forgetting like the negative sign or
The
the
negative. That is exactly. That's what I
Yeah.
was gonna say too. I like the way that you just showed, like on the number line, like thinking of it going to left or right.
Yeah.
I like that way better because it helped me catch. Hold on, you're starting at -8.
Yeah.
And you're going the other way on the number line, but you're still in a negative area.
Yeah, exactly. That's
Yeah.
exactly right. So for everybody else, right, if we start at -8 and we move 1, 2, 3, 4, 5, we sort of have to understand what number are we at now?
Starting at right.
Well, we started at -8, so this should be -7, -6, -5, -4, and
Yeah.
then -3 is the result.
But we're still on the left side of the number line.
Yeah, we're still on the left side
Yeah.
of 0 because 0 would
Yeah.
be over here, 2, 1, and 0 is over here. We're still in the negative area.
Yeah, that really helped me with the sign.
Yeah.
Yeah.
So there is a quick and dirty trick that you can do when you're adding numbers with different signs. And I think that a lot of people probably do this intuitively, but then they forget what they're supposed to do with the sign afterwards. So let me give you that trick. Okay. So when
Can you
you
go back real
add,
quick?
what's up?
Can you go back real quick? I need one more.
Okay,
Yeah, me too. I was like, I didn't want to say anything.
you got it.
Sorry.
Does anybody have any other questions or comments before I go on to the next topic though?
No, that's not the one. It's the pay. I think it's flip it over to the other
Ooh.
side.
My bad. There we go.
Right there. Yep, that's the one. Thank you.
You got it.
The way I look at it is whatever the first number is, if it's a negative or positive, that's where I'm gonna start. And then the next number, whether it's a negative or positive, that's the direction I'm gonna go.
Yeah. Right. And that's the intuition that you sort of have to have. But I can guarantee you that what I've showed you right now about moving that many units, like if the numbers are big, it's going to get harder to figure out. Like you don't want to draw this out every single time. It works to visualize smaller problems, but for larger problems, or if we have to add multiple numbers, not just two, then it becomes a little bit cumbersome, and we need a sort of a shortcut or a rule of thumb that we can use.
Okay.
That's what I was. Yeah.
So that's what I'm going to show you now. So adding numbers with the same sign. This is going to be the rule. Sorry, let me go ahead and, I was thinking two thoughts at once, wrote the wrong thing down. So if we're adding numbers with the same sign, and that was the first set of examples that we looked at, you just add the numbers and keep the sign. That is the rule. Add the numbers.
Yeah, you're lagging now.
The common sign. Okay. Am I still lagging?
I don't know until we start
Until we
going
start.
again.
On my end, yes.
I just thought I'd let you know.
No, thank you. Hopefully the recording isn't lagging. I don't think that it is.
And you said adding numbers with keep the same sign?
If we're adding numbers with the same sign, then you're just going to sort of ignore the signs, add the numbers, and then keep that common sign. So
It's lag.
for example, if I have negative 25 plus negative 10,
why is so many of y'all today? Jabari's Jones. Oh, Jabari's, you got 9 detentions. One number you get.
all right, remember to keep your background muted if it's loud. Okay, what should this result be?
Negative 35.
Yeah, so we're just gonna add the numbers. So in my head, I just look at 25 plus 10. That's 35. They're both negative, so I'll just keep that negative sign. And obviously with positive numbers, that's a lot easier to manage, right? Like 43 plus 27. Well, I know the result should be positive here. This is pretty intuitive. So that should be 3 and 7 will give me 10. So I should have 60 and then that should be 70, right? So that's rule 1. Adding numbers with the same sign. Rule 2 is a little bit more complicated. This is adding numbers with different signs. Subtract the smaller from the larger. and keep the sign of the larger. Okay, so example. Let's do -43 plus, let's go with 58. Does anybody know what this should be?
So you froze for like a few seconds.
Okay, we're just gonna have to deal with whatever the lagging is. I'm sorry about it. There's nothing I can do. Can you hear me now?
Yes, we can hear you now.
I mean, I
So,
can hear you.
is the
Yeah,
answer
I can hear
15?
you.
Okay,
The answer should be the positive 15, right?
that's a good question. I wrote this down and I can't even do it in my head. So I'm just gonna use the rule, right? I'll take subtract the smaller from the larger. So that means I need to take 58 and I need to subtract 43. Okay,
Five.
and that's gonna be 5, that's gonna be 1. The larger number is positive, so my result should be positive. So I should have a positive 15. Okay, now sometimes the textbook or Hawks will complicate this and say, subtract the absolute values, taking the smaller from the larger. And that's sort of what we're doing here. We're ignoring the signs at first and taking the bigger number and subtracting. And then we're worrying about the signs later. Okay, so that's gonna be a rule of thumb that should get us on track with adding numbers that have different signs. So what I want to do is give you guys an opportunity to get some practice problems in. I'm going to write some problems down and then give you the opportunity to take about 10 minutes to solve them. So let's do this. Practice. Okay. Well, one more for good measure. Okay. Okay, so I'm gonna give you guys 10 minutes or so. when you're finished, you can go ahead and type done in the chat, just so I get an idea of, when most of you begin to finish up these problems. And also remember, I haven't said this explicitly, but we're trying to do these by hand. We're not trying to use the calculator right now, because obviously the calculator will spit out the answers. We want to really develop these arithmetic skills so that when we have to do larger calculations, we can just quickly do some of the basic arithmetic to get us to more complex problems. Okay, it's looking like about half of us, maybe a little less than half are done. I'm going to continue. There we go. We got some more rolling in here. I'm just going to work the first couple. But if you're still working on some of these last ones, just continue doing that. I think that the first couple were pretty straightforward, right? 10 plus 3 is 13. Didn't have to draw any number lines for that one. -5 plus -9. If we use our rule that we need to add the numbers, keep the common sign, these are both negative. So my answer should be negative. So I'm just going to take the numbers 5 and 9, add them together. That should be 14. But it should be -14. And another intuition that you can use here is that if I have a balance in the bank of -$5, and then I spend $9, right? And when you spend money, you're sort of losing money, so it's negative. Well, how much should be in the bank? Well, I should owe the bank a total of $14, right? So if I owe them money, then I'm in the red, which means I have negative value. Okay. Now these ones with decimals, we haven't looked at decimals yet, haven't really talked about them, sort of assuming that we know how to work with them. And that might not be the case, but whatever it is, we still have to just add these numbers, keep the common sign since they're both negative. So we can line up our decimals since that's how we add numbers with decimals. And we're just going to add those numbers, ignoring the sign. So we should get 9 here, 3 here. That decimal just goes straight down. Okay, and that's not to confuse it with our rules for multiplying and dividing decimals. That's a different set of rules. But in any case, when we add them, we just line up the decimal, add our numbers up. So we should have negative, since these are both negative, 3.9. Was everybody okay with these first three?
Yes.
Okay. We're going to do the same thing here, line up the decimals, but here we have different signs. So we have a different rule to apply for number 4. Different signs, which means we need to take the numbers, take the larger one and subtract the smaller, and then keep the sign of the larger. So this is our larger number. So our result should be negative. So I'll go over here and give myself some breathing room. And take 15 minus, and we want to put 2.8 like so. If we want to call this 15.0 just to line up that decimal, we can. And now we can subtract. Well, we'll have to borrow since that 0 can't subtract an 8, but now we can go ahead and subtract. That gives us a 2. This gives us a 2, and we still have a 1. Okay, but since the larger number was negative, our result here should be negative. Okay, and then we can use that money intuition to say, if I had negative $15 in my bank account and I deposited $280, I should still have negative because it wasn't enough to clear my negative balance. We're going to run into a similar situation here because we're adding negative and a positive number, right? Different signs. So I'll take the larger number, and we're just going to work with its absolute value, which is 9.5. We'll subtract the smaller one. Here we have to borrow. So 15 minus 7 should be 8. And then 8 minus 8 should be 0. Since the larger is negative, we should have a negative result. Was anybody having any questions with these two?
Yeah, I got lost on the decimals, but you just explained it to me.
Okay.
That 9.5 became a positive. Or no?
No, it didn't become a positive. We just considered working with the positive first, right? So when you want to think about these numbers, we want to think about their sizes, right? If I had if I owed the bank $9.50 and I only paid back $8.70, right? Well, I owed more than I paid back. So I should still have a negative result. But remember, when we're adding numbers with different signs, the rule is take the larger number, subtract the smaller one, keep the sign of the larger. So we took the larger number, which was 9.5, subtracted 8.7, and we kept the sign of the larger. Does that make sense?
Yes.
Okay. For this last one, you'll notice that with addition, it doesn't make a difference what order we add numbers in. And we'll talk about that here in a second. But we just take two numbers at a time, work with that, and then we'll get the result and then bring the other number into the mix. So you have to take your time with some of these, but if we wanted to start off with 9 and 13, they're opposite signs, right? They're different signs. So what we need to do to process this part is take the larger number, which is 13, subtract the 9, and we should get 4. And it should be positive 4 because this was a positive 13 and that was the larger number. Is everybody okay with that?
Yes.
Okay. Well, once we've taken care of the -9 and the 13, we have a result of positive 4. We still need to add that to the -11 that we had left over. They're still different signs. So that means we have to use that same process again. So we'll take the larger number, in this case is 11. We'll subtract the smaller number. So 11 minus 4 should be 7. And then since -11 is the larger number, or 11 is the larger number, we're going to keep the sign of the larger. So this should be a -7 as our result. Anybody have any questions though?
Can you do another example like that one? Because that one threw me off. I had a completely different number.
Yeah, can you tell me how you worked it out?
I was completely wrong because what I did was I added the two negative numbers and then the 13, subtracted the 13.
Yeah, and we'll talk about that exactly. We should have gotten the same thing. So that process would work. Let's go ahead and take a look at number 6 again, right? We had -9 plus 13 plus -11, right? And so you're saying that we want to deal with the negatives first. So we
Mhm.
take 9, the -9, and the -11. Okay, so if I'm going to take -9 and add that to -11, what should I get?
-20.
Yeah, because we're just adding the numbers, keeping this common sign. So that should be 20 and a negative. Is anybody confused as to why we should get -20? And again, we should have -20 because think about like money. If I have -9 in the bank and I spend $11 that I don't have, then I should owe the bank more money. Okay. So now we can take that result, since we worked with the -9 and we worked with the -11, we'll take the result and we'll add 13. But now we have two different signs. So the rule is different, right? Again, you can still think about money. If I had -20 in the bank and I deposited 13, 13 is not big enough to take me into the positives. So I should still be negative. But let's go ahead and use our rule here. We're going to take the larger number. We're going to subtract it, or we're going to take the smaller number and subtract it from the larger. So 20 minus 13. And we could borrow, you know, we need to borrow here so that we have 10 and 1 there. 10 minus 3 is 7. 1 minus 1 is 0. But we need to keep the sign of the larger. So we need a -7 here.
Yeah, that's the way I did it.
Yeah, as long as we got the same answer, we should be good.
Yeah, I
wait,
got -7. It was just the way we did it was 2 different ways.
Yeah, exactly. That's exactly right.
Okay.
So you don't have to do it my way. In fact, notice that, you know, the first way we did it, I went from left to right. But when it comes to addition, the order didn't seem to really matter. If we wanted to add the negatives first, we could have done that and then added the positives later. That's fine. And that leads me to my next discussion of these rules for addition. Okay. And you might intuitively know some of them, but I'm going to give them a name. Okay.
Can I
So
ask you a question?
yeah.
Can you just tell me so I can know if I got them wrong or not, like the answers for these? Because I did all of them.
Yeah.
But if I could just like get the answers real quick, so if I got to go back and
Yeah. The
Thank
answers I
you.
boxed in, right? So the first one was 13.
Yes.
Second one was -14.
Yep.
Third one was -3.9.
Yep.
Next one, the fourth one was -12.2.
Yep.
The fifth one was -0.8.
Yep.
-7 was the sixth one.
Yep. Okay, cool. Got it. Thank you.
You got it. So the rules of addition. This is going to have some vocabulary here that we have to, you know, become privy to, or just get comfortable with. The commutative property of addition is what we just went over. This property says that the order or the position of the numbers that we're adding together doesn't matter. The order in which numbers are added does not affect the result. Okay. So for example, it should be intuitively clear to us that 5 plus 2 is the same thing as 2 plus 5. When it comes to adding more than 2 numbers together, like we did with the last problem, again, it doesn't matter what order in which you add those numbers. You could add the first 2 numbers, get that result, and then add the third number, or you could add the first and the third number, that's fine, and then add the second number in later. The order of addition should not matter if we are just purely doing addition. Okay. If you ever get a different result working it a different way, then one of those ways you made a mistake because they should lead to the same result. Does that make sense?
Yes, it makes sense.
The second property is called the associative property. And this property says that the grouping of numbers, usually with parentheses, does not affect the result of addition. Okay, and I think this is clearer to, this is will be a little bit clearer if we add 3 or more numbers. So if I had, for instance, 7 plus 4 plus 2, I should get, let's see, if we use the commutative property, 7 and 2 is 9, and then at 4 should be 13. So this should be 13. Or we could have done 7 and 4 is 11 plus 2 is 13. Using the commutative property, it works either way. But now let me ask you this. Let's say I had 7 plus 4 plus 2, exact same numbers, but let's say that I decided to put parentheses around these 2 numbers in the back. Do you think that will change the result?
No.
No.
Okay, well, it shouldn't, right? I gave you this rule. I told you straight up before we started this that it should not change the result if I throw parentheses into the problem. If I
If
group
you're
these,
only purely adding,
yeah, if we're just purely adding, nothing should change. The parentheses that I threw into the problem is just saying, okay, if you remember your order of operations or PEMDAS, this is telling you, okay, do the parentheses first. 4 plus 2 is 6. And then we can add the 7, still get 13. So clearly the parentheses didn't matter if we are just purely adding. Similarly, if I were to say, okay, we have 7 plus 4 plus 2, and I want to figure out what that is, but now I'm going to change the problem by putting parentheses around the 7 and the 4, will that change the result?
No.
Well, it shouldn't if we believe this property to be true in all cases, and it is. We can work it out for ourselves. 7 plus 4, like I said before, is 11, plus 2 takes us back to 13. So it didn't matter where we threw the parentheses. If we group a couple of the numbers together or a few of the numbers together, and we're just adding, we're still going to end up with the same result. Okay, and then there's one more property of addition that I've sort of alluded to, and that is the additive identity. And I think that this one is probably the easiest one. That is a number plus 0 is the original number. Right, that adding 0 does not change the result. So if I have a number, let's say 25 plus 0, that should be pretty clear. That should be 25, right? Because we haven't added anything, right? 0 has a magnitude or a size of 0. There's no value there. It is a number. I don't want to say that it's nothing, but in terms of moving us on the number line, it does not move us left or right. We stay in the same location. But here's another example that I think might be clear later on when we start really working with variables. That is, if I have the variable x plus 0. Does anybody know what that should be?
X.
Yeah. Remember, a variable is just a number. It's a placeholder. We just don't know its value. So x plus 0 is the same thing as x because we have not added anything to the x. We haven't changed its value. Okay. Does anybody have any questions about that?
Just to be clear, that last example is not balancing in an equation.
No, it's just
Okay,
saying
that's different.
a variable plus 0 is equal to what? And it's
X.
just equal to itself. So the additive identity is saying a number or a variable plus 0 is just whatever you started with.
So can I add, would it be okay to say a number or a variable in my
Yeah.
notes?
Yeah, you can put
Okay.
or a
slash-
variable. It's just
Okay,
the original
thank you.
number or variable.
All right.
Yeah, and we'll work with variables a little bit later on. But you can see that, you know, it's sort of pointless to write x plus 0 if we know that the 0 doesn't add any value to what we originally started with. So we could say that if we wanted to simplify this, then it would just be simpler to write x since 0 does not add any value. Okay. Well, this last section that we have to cover is finding the area of polygons, and this is actually chapter 6.2. And the reason why I sort of put this at the end of our addition problems is because when we're finding the area, sorry, not the area, the perimeter. My bad, I'm on the wrong side. There we go. Perimeter of polygons. The perimeter, well, you know, if I asked you what is the perimeter of your property, or, you know, if you needed to walk the perimeter of your property, you would just say it's the outside boundary of that property, right? So a polygon is just a fancy word for saying shape that has usually straight edges or straight sides. It's a closed figure or closed shape.
Does that mean we add up all sizes, right?
Yeah, so the perimeter is the sides of the shape or the polygon that were given. Okay, so to calculate this, you will add the length of all sides. So there are some regular polygons that you'll run into in your homework in Hawks. So obviously we sort of know what some of these shapes are. A triangle is a 3-sided polygon. So if I had a triangle like so, doesn't matter what type of triangle, that's not what we're interested in here, then the sides of the triangle, if we labeled them A, B, and C, and we wanted to find the perimeter of a triangle, well, then I would just add up whatever those numbers are, A plus B plus C. That would give me my perimeter. There are some other shapes that maybe have simpler formulas for perimeter, but just because they tend to be like easier shapes to work with. So let's start with rectangle. All right, let's take a look at a rectangle, just a generic rectangle. And in an ideal setting, rectangle has 90 degrees for each of the corners. So that's what they usually put these little boxes in the corner for, to indicate that there's 90 degrees, perfectly straight edges. And then if we needed to find the perimeter of a rectangle, we could label all the sides A, B, C, and D, and then just add them up. But typically, you know, when we're measuring, you know, like a flat screen TV, you might measure this as the length, and you might measure this as the width. So we'll use L and W. Well, it turns out that this side and this side of the rectangle should be the same length if it's a perfect rectangle. and this side should be the same length. So we don't really have to label all 4 sides of the rectangle in that case. What we should say is we need to add up the L and the L, whatever that is, and then add the W and the W, because there are 2 of those sides, and that will give us the perimeter. But there's an easier way to write this down. So if we have 2 of these L's, then that would be 2 times L plus 2 times W. And so this is usually the formula that's given for the perimeter of a rectangle. But again, if all of the sides are labeled, just add up all of the sides. A square is a perfect type of rectangle. So I'll go ahead and throw it here. I'm going to do my best to do a square. There we go. Not my best work. So a square is a 4-sided polygon, just like a rectangle. The only difference here is that for a square, the length is equal to the width. So all of the sides have the same length. Which means we just need one label. I'm going to put a cursive S here to label the side, just so that we don't confuse it with a 5. But all of the sides have the same length. So what I could do, if I wanted to calculate the perimeter of the square, I could do the side plus the side plus the side plus the other side, right? The 4 sides. Or I could say that that's just 4 times the length of the side. And that's usually the formula that's given for perimeter of a square. Does anybody have any questions so far? Okay. Gonna move on to the next shape. Let's go with a parallelogram. This is another 4-sided polygon. With both pairs of opposite sides parallel and equal in length. So for this one, we can think about having a rectangle that we just sort of lean over on its side. So this side should be equal to this side. Those are equal in length. And then this side should be equal to this side. And notice that we don't have right angles for this parallelogram. The opposite angles are equal to each other, like so. But essentially, for a parallelogram, you have, let's call this side A, and this side is A. This side is B, and we'll call that B. So again, if we needed to calculate the perimeter, all we need to do is go around and add up all of the sides. So the perimeter would be A plus B plus A plus B if we wanted to walk around in this direction, right? But since we have some A's together, we have 2 A's. we could just say that this is the same thing as 2 times A plus 2 times B, which is very similar to the formula for a rectangle. Finally, we have a trapezoid, which is a 4-sided polygon with one pair of opposite sides that are parallel. So we can think of it like a pyramid shape, or like the Pizza Hut symbol. This side and this side are parallel, but if we were to extend the lines for these other sides, eventually they would intersect, so they're not parallel. Okay. And so there's no fancy formula for a trapezoid. If all the sides are labeled A, B, C, and D, then the perimeter will be calculated as such: A plus B plus C plus D. Again, all of these could be calculated just by adding up all the sides. That is what perimeter is. Perimeter means add up all the sides. Okay. So you may get shapes that have that differ from these regular polygons. And in those cases, you'll sort of have to do some mental tricks to figure out what the sides of those shapes are. So let me give you one example.
Question real quick.
Yeah.
How come sides D and B aren't the same side letter? Like, why isn't it A plus, like, A plus C plus 2B?
Oh, it could be, right? These could be the same length.
Okay,
I think, in fact, they have to be the same length.
okay.
Yeah.
Just checking.
So as long as those are the same length, then you can just say 2 times that number.
Okay.
Yeah, good question, good comment. So you could have polygons that look a little bit different, that look like they're the composite or they're made up of other shapes. So you could have something that looks like this. And let's just pretend that these are straight lines, that this is given by 15 feet, and this is given by 12 feet. Okay. Well, how would we calculate the perimeter of something like this? It'd be a little bit harder to figure out, but what we could do is imagine that we completed the rectangle, right? And then what we could do is say, if I completed the rectangle, then I would know all of the side lengths. They would be 12 and 15 here, right? And then all I would have to do is cut out or subtract that little portion in the corner.
So how you know what that little portion in the corner is?
Yeah, let's take a look at that. Let's try to figure that out. Well, if we think about this little portion in the corner, actually, I'm thinking of area right now. we actually don't have to cut out that portion in the corner. Let me go ahead and say, we'll pick back up on this question next time, right? Because we're already at a time, it's at 10:30. So just forget that I drew this. We'll pick back up on this next time.
Okay.
If you guys have any questions, you're free to hang back for a few moments with me if you need to resolve some things. But otherwise, I'll see you guys tomorrow morning at 9:10.
Can I, it's Marisa. I was